Good afternoon. This is a quick review of oxidation numbers and how to find them. So the rules for oxidation numbers are listed at the top. Atoms in a pure element have an oxidation number of 0. So for example, solid sodium, which is just the element sodium, has an oxidation number of 0. Hydrogen gas, which is always in pairs, H2, remember the rule of 7, you have those 7 diatomic elements, those will all have an oxidation number of 0. Argon gas, 0, it's a noble gas, so it's just by itself. And sulfur can be present in molecules of 8, but as long as it's pure sulfur, it has an oxidation number of 0. Okay, number 2, the more electronegative element is going to be negative, the less electronegative element is positive. So between these two, oxygen would be negative, carbon would be positive. Because this is closer to fluorine, so we know it has a higher electronegativity because of Coulomb's law. It's smaller and has a greater nuclear charge. Over here, this one's kind of tricky because it's written in opposite. Hydrogen has a lower, it's less electronegative, so it's going to be positive. This one's more electronegative, it's going to be negative. And usually it's always written positive, negative, but this is an exception. Okay, carbon, nitrogen. Carbon is farther left, positive, nitrogen more electronegative, it's going to be negative. Fluorine always has an oxidation number of -1 because nobody can pull the electrons from fluorine. It will win every time because it is the smallest with the greatest nuclear charge. Oxygen is almost always -2, two exceptions, hydrogen peroxide and oxygen difluoride. Hydrogen is +1, except when it's with metals, which is very rare. The sum of the oxidation numbers of a neutral compound is going to be 0. So if you add up the oxidation numbers of carbon and the 2 oxygens here, you should get 0. The sum of the oxidation numbers of a polyatomic ion is equal to its charge. So what I was going to say is cyanide, we're going to add up the carbon and the nitrogen oxidation numbers, and we will get -1 for an answer. Number 8, these rules apply to covalent and ionic, so we can do oxidation numbers for both. Monatomic ion has an oxidation number equal to its charge. So if I have Na+, that's one atom with a charge, it's going to be +1 oxidation number. Remember, the charge clock is very helpful. Some of them don't work all of the time, but inside we have the group number, starting with 18 at the top, which is the noble gases. They will have a charge of 0. And then down here at the bottom is group 14, which would have plus or minus 4 as their charge. And then we have 1, 2, 13 because we skip that D block, 14, 15, 16, and 17. Group 1 is going to be +1 almost always. Group 2, +2. Group 13, nitrogen's group, is usually +3. But it doesn't have to be. I'm sorry, that's the wrong group. Over here is nitrogen's group, it's -3. 16, oxygen's group, -2. The halogens, group 17, -1. Okay, so these are the groups on the periodic table, and these are their typical charges, though there can be exceptions, especially on the bottom half of this clock. Okay, so let's do some examples. Hydrogen, +1, this is not a metal, +1, and it's going to be +1 over here as well, but fluorine, that's an easy one, it's always -1. Done. Oxygen, -2. Oxygen here, this is the pure element oxygen, so it's going to be 0. Oxygen here in this compound, -2. There are 3 of them, so total negative charge would be -6. It has to add up with nitrogen to give us -1. So -6 plus what equals -1? +5. You can do that as an algebra problem if you need to write that out. Calcium, 2+, because it's a monatomic ion. Carbon dioxide from up here, -2. There's 2 of them, so a total -4. That means carbon must be +4. Hydrogen is +1 here. The nitrogen needs to balance that out. So there are 3 of these. That means it has to be -3 for nitrogen. For the cyanide, this -1 means the two have to add up to -1. And we have a nitrogen is usually over here, group 15, -3. If you have to add X, carbon, plus the -3, and it has to equal -1, our answer is +2 for this carbon, which is kind of strange, but it can happen. All right, down here, fluorine outpowers the oxygen, and it is going to be -1. There are 2 of them, that's -2. That means this oxygen has lost 2 electrons, it's +2. This is +1, monatomic ion. Over here, fluorine is always -1, and there's 6 of them, so this must be +6 to balance it. Oxygen is -2, hydrogen is +1. There are 4 oxygens, so a total of -8. +2, that's -6, so this has to be +6. This sulfur is +6 to balance it. Chlorate has to add up to -1. So we have -2 for the oxygens. There are 3 of them, so -6. What plus -6 is -1? That is +5, which is weird on a chlorine, but it is possible again. Okay, manganese sulfate. Sulfate's going to add up to -2. Sorry, its charge is -2, so this is +2. So that's not super hard. The oxygen, -2, and there are 4 of them, so -8 +2. What charge do I have on this sulfur? That would be -8 +2 gives me -6 +6 to balance that -6. And down here we have another compound. This is manganate. There are 4 oxygens, each is -2, -8. They have to add up to -1. So what plus -8 is -1, and the answer is going to be 7. All right, thank you.